Hey y'all. Today's objective is inverse functions. Inverse of a function, it's when the independent and dependent variables are reversed. So you've done inverse operations. The inverse operation of addition is subtraction. The inverse of a square is a square root. So the inverse of a function is an inverse of a function. It's kind of like a reflection when you exchange the x and y values now, or when you reverse them. The reason we would need to know the inverse of a function is if we want to undo a function back to undo a function to solve a problem. So the notation we use, instead of f of x, we are going to have f to the negative 1. It's not an exponent. This is inverse function notation. So this reads f inverse of x. Not f of x, but f inverse of x. And sometimes you'll see g equals f of inverse, or g of x is f inverse of x. So these are the notations that you might see. Not all inverses have not all functions have inverses. So we're going to talk about that in class. Not all functions have an inverse, and you're going to use mapping to check. So I'm going to show you mapping, and I'm going to show you how to write an equation for an inverse. Okay. So, do these functions have inverses? I'm going to show you a couple of examples. Example 1. F of x equals x plus 3. So to determine if something is a function, you would use the vertical line test, or you would look at the domain. The domains can't repeat. Well, the reverse is opposite for inverses. We're going to make a table. We're going to make a table, list of x and y values. So in right here, negative 2 plus 3 is 1. Negative 1 plus 3 is 2, 3, 4, and 5. So over here for my range, I would put 1, 2, 3, 4, 5. That's not a good marker. And then I would map. Negative 2 maps to 1, 2, 3, 4, 5. When you try to determine if something is a function, you look this way. To determine if something has an inverse, you look the other way. Is there any range value who maps to two different domains? And this answer, everybody is paired up with its own, so this would, yes, it would have an inverse. Example 2, f of x equals the absolute value of x. So to determine if it has an inverse, we need to look at mapping. So let's plug in some values. Negative 2, the absolute value of negative 2 is 2. The absolute value of negative 1 is 1. 0. The absolute value of 1 is 1, and the absolute value of 2 is 2. So you notice we have 2, 1, 0, 1, 2. When I map, negative 2 maps to 2, negative 1 maps to 1, 0 maps to 0. 1 also maps to 1, and 2 also maps to 2. Now, if we were determining if this was a function, it would pass the vertical line test because there's not a repeating domain. So this is a function. If we're trying to decide if it's an inverse, if it has an inverse, we go from the range back. Is there any range value that maps to two different domains? And yes, 2 maps to two different domains. It maps to negative 2 and it maps to 2. 1 maps to two different domains. It maps to negative 1 and it maps to 1. So this would not have an inverse. Okay, would not have an inverse unless we restricted the domain, but we're not talking about that quite yet. So here's the key. Ranges can't repeat for the inverse function. So if you have ranges that repeat, that means there's not going to be an inverse. Here's a U-try. F of x equals x squared minus 5. I want you to set up a table of values, or you can map, but even from the table of values, you can see if something's going to repeat. So pause it, work this one out, and then check. So I'm going to make a table of values from negative 2 to positive 2. And when I substitute them in, negative 2 squared is 4, minus 5 is negative 1. Negative 1 squared is 1, minus 5 is negative 4. 0 minus 5 is negative 5. So what happens when I type in 1? 1 squared is 1, minus 5 is negative 4. 2 squared is 4, minus 5 is negative 1. And you can see that my range values are repeating. I have the same range values, so the answer is no. This does not have an inverse function right now. It does not have an inverse function. So, to write the equation of an inverse, there's two things you need to do. To write the equation of an inverse, first, you have to switch x and y. Then you're going to solve for y. I'm going to show you. But this only works if there is an inverse. Alright, so example 1. This is the same number 1 from before. X plus 3. You rewrite it, y equals x plus 3. So I rewrote function notation using a y. And then I switched the x and y values. So where it says switch, you switch the x and y values. So now I have x equals y plus 3. You solve for y, so I add 3 to both sides, and now I have y equals x minus 3. To write it in inverse function notation, I'm going to write f inverse of x equals x plus x minus 3. So you see x minus 3. You switch x and y, and you solve for y. Here's a table of values that I wanted to put you in here. Negative 1 plus 3, 0 plus 3, and 1 plus 3. So I just want to show you how they really are inverses. They reverse each other. I took my range, 2, 3, and 4, and now it's my domain, 2, 3, and 4. So 2 minus 3 is negative 1, 3 minus 3 is 0, 4 minus 3 is 1. So if you compare my tables are reversed, and that's what I meant in the very first slide when I talked about you reverse the x and y, you reverse the independent and dependent independent and dependent variables. I have reversed my chart, and that's the definition of an inverse, is when the independent and the dependent variables are reversed. Right. Example 2, f of x equals 3x plus 6. I rewrote it using y. And then I switched my x and my y. I put my x here, I put my y here. Now I'm going to solve for y by subtracting 6 on both sides. And I get x minus 6 equals 3y. Then I'm going to divide both sides by 3. And I get x minus 6 over 3 equals y. But I want to rewrite that in inverse function notation. So I'm going to say f inverse of x is x minus 6 divided by 3. And then I was just going to show you a table of values, but I'm not going to show you that. I just want you to see the process of writing the equation of an inverse. Right. So write the equation of an inverse. Here we go. I rewrote it, I switched my x and my y's, and now I'm going to solve. I'm going to subtract 4 from both sides. So I get x minus 4 equals negative 3y. Then you're going to divide both sides by negative 3. So x minus 4 divided by negative 3. That is the equation of my inverse. So f inverse of x is this. All right. I'm going to skip number 4 just for a moment, go back to number 4, number 5. F of x is the square root of x minus 5. I rewrote it using y, and then I switched my x and y value. I need to solve for y, so I need to square both sides. And I get x squared equals y minus 5. Then you would add 5 to both sides. So I would get x squared plus 5, and that is my inverse equation. Now going back to example 4, this one is just a little bit tricky, and I'm going to explain why. You see y equals x squared. I switch my x and my y. To solve a square, we would take the square root of both sides. And I see that the square root of x is my inverse. The reason I have a star by this one is because what kind of numbers can we take the square root of? We can only take the square root of positive numbers. You can't take a square root of negative numbers. That gives you imaginary numbers. So when you see this, the reason I have a star is because we would have to restrict the domain. And what that means is we're only talking about positive numbers. So x would have to be greater than or equal to 0. Because if we have negative numbers under a radical, then it wouldn't work. So for this inverse to work, we would have to only have positive numbers. So we're going to practice more of this, but hopefully you understand how to determine if a function has an inverse and then how to find the equation of an inverse.